I'm Sneha. I'm a PhD student at Columbia University working in biomedical engineering and a mentor for Magic. I've been mentoring Saumya on her journey into biomedical engineering for the past 5 months to learn how to use microscopes and understand where their role falls in the broader engineering field. Saumya is an extremely bright and inquisitive student and has picked up advanced engineering concepts remarkably quickly over only a short period of time. Her confidence in digesting and summarizing new information independently has grown, and it's been a pleasure to see her applying her new skills and coming up with ideas for her project. Saumya was inspired by a family friend who works in biomedical engineering and has decided to make an educational demo to delve deeper into the field. She has worked really hard on her project, so I'll let her take it from here and show you all her demo. Over to you, Saumya.
Thank you, Sneha. Next slide, please. My mentor is Sneha. She studies at Columbia University, and she's from London. Next slide, please.
Actually, Saumya, the camera is there, right?
Yeah.
You
So
need to
actually,
come
yeah, be in the middle here, and we can see. Yeah.
No, it's okay.
We'll do it differently today.
This is just the way it is today.
Yeah,
I don't know what to say. Sorry. Go ahead. Next slide.
My project is biomedical engineering. It's a deep dive into light microscopy. And my interest, as Sneha said, was inspired by a friend of my mom who works in the field. And I have learned the principles of microscopy and about CT scanners and also MRI scans. And I've been reading literature reviews and university level text papers. Next slide, please.
Go to the next slide.
Some of the highlights of my magical experience were learning from Sneha. And one of the major points that I learned in magic was being able to tell a story through a presentation and being able to accurately present ideas and information. Next slide, please.
One more slide.
Yes. As stated earlier, my project is a deep dive into biomedical engineering with a focus on light microscopy. The structure of the presentation is as follows. We start with an overview of biomedical engineering, then we focus on imaging, followed by a deep dive on microscopy, and we conclude with a light microscope demonstration. Next slide, please. What does biomedical engineering mean? Next slide. It refers to the application of fundamental theories, analytical practice, and engineering principles to create equipment, devices, computer systems, and software. Next slide, please. The purpose of biomedical engineering is to advance medicine by creating medical devices, pharmaceuticals, and new disease biomarkers. Next slide, please. Some of the subdivisions of biomedical engineering are genomics, computational biology, tissue engineering, and imaging. Next slide, please. Next.
One more.
Yes. We will now focus on imaging in biomedical engineering. We will go over definition, CT MRI scans, and microscopy. Next slide, please. Imaging refers to the knowledge of physical properties of electromagnetic energy, signal analysis, and rapid display, which creates the generation of the image of a body part or function. Next slide, please. CT and MRI scans both have detailed images of internal structures, are commonly used in diagnosing and staging cancer, and are the two main 3D imaging modalities. Next slide. CT scans are a computerized X-ray imaging procedure in which a narrow beam of X-rays is aimed at a patient and then is quickly rotated around the body using ionization, and then signals are processed by the machine's computer to generate 3D images of the body. The standardized units of image intensities are used to figure out the different parts of a body part or its function. For example, 0 equals water and -1000 equals air. The image shows CT images of lungs affected by COVID, and you can clearly see the fibrotic tissue inside the images, and white streaks represent lung damage. Next slide, please. MRI scans are a non-invasive imaging technology, which, unlike CT scans, do not use ionizing radiation. They release energy when radio waves are applied, and the magnetic properties create a 3D image. In addition, MRI scans are also safe for children. Next slide, please. Now we move on to the main two-dimensional imaging modality, microscopy. A microscope aids in viewing microorganisms that are too small to be seen by the human eye. There are some different types of microscopes, which are light microscopes and electron microscopes. Next slide, please. Next slide. As stated earlier, there are two microscope types, light and electron. Next slide. Light microscopes magnify images using optical lenses using light waves. There are two types, simple and compound microscopes, which use one biconvex lens or two lens systems respectively. This image shows how one biconvex lens works. As shown in the image, a convex lens placed directly in front of the image, in front of the human eye, is used to magnify an object. It's designed to bend or refract light rays as they pass through it, which allows for an enlarged image to be produced when viewed at an angle theta. The object is placed at a distance of DO from the lens, and the enlarged image is at a distance of DI from the lens. F is the focal point of the lens, the location at which the image will not be blurry. And the lens has a magnification factor of M, the size of the original object, or H. The focal length can be changed on how the lens bends the light, which is a property based on the shape and thickness of the lens itself. Next slide. Electron microscopes are different from light microscopes because the magnification uses electromagnetic lenses and an electron beam. There are two types, TEM and SEM. Next slide, please. Now we will compare the different types of microscopes. We have already discussed light microscopy. Now we will move on to electron microscopy. TEM uses a beam of electrons that passes through the specimen, whereas SEM uses a beam of electrons that reflects off the specimen. TEM has a 1 nanometer resolution, whereas SEM has a 10 nanometer resolution. Next slide, please. Due to this, you can look directly inside a pollen grain in TEM, whereas in SEM, you can only see the outside and multiple particles. Next slide, please. Now we will move on to a light microscope in action. To combat the issue of not being able to use an actual light microscope, we use a foldscope, which is an inexpensive and high-quality paper microscope, which can attach to mobile phones for imaging and is portable. There's a range of magnifications, which is 50x to 340x for tiny microorganisms. We will discuss what's the difference between light microscopes and foldscopes, and I will show you a demo. Next slide, please. Foldscopes versus light microscopes. A foldscope is lightweight and portable, has a range of 50x to 340x. The lens is a single glass ball, and it costs about $40. A light microscope must be on a lab bench. Its range is 500x to 1500x. Lenses are made of multiple pieces of curved glass, and it ranges from $200 to $400. Both use visible light and a system of lenses to magnify images of small objects. Next slide, please. My experience with Foldscope was that it was easy to use because it was pre-assembled and there were clear instructions, and I used it multiple times for different slide collection and viewing, and I was able to use all of the different magnifications. Next slide, please.
That's the video?
Yes.
I'm not seeing the video.
Yeah, there's no video?
That's supposed to be, she said.
Oh, there it is.
I can just click on it.
It's probably still loading, so we have to be extremely patient. There we go.
Oh, that is. Woo.
Let's see how long this loads.
Please tell me when you press play.
I have pressed play. It's loading.
Hi everyone.
Okay, there we go.
Hi everyone. This is a foldscope, a revolutionary invention that has not only furthered many students in their understanding of microscopy, but has also provided
A relatively inexpensive option of doing so.
How long was the video?
It was
It's
50 seconds. It was
Oh,
a short
50
video.
seconds, okay.
There
an
is-
inexpensive option for doing so. The foldscope has three main parts: the lenses, the slide, and the imaging device. In order to make the slide, first an adhesive circle is placed under the hole in the trading card. The sample is placed on the sticky part of the adhesive. Finally, it's covered with another circle. The slide is then inserted into the foldscope, and then a phone is attached for viewing. Thank you.
Next
All
slide.
right, next slide.
I want to
Yeah.
pause this.
Let's take that one. Okay.
Here are some samples that I have imaged myself in 50x to 340x magnifications. The slide which you saw in the video was actually my collection of a mop that I looked at under 140x and 340x, which you can see up here. And I also imaged a cross-section of a fern in 50x and 340x, and a blood sample of type B in 140x and 340x. I used my mom's blood for this sample. Next slide, please. Thank you for listening.